Hi everyone, and welcome to our video on concavity and inflection points, where we will first be analyzing graphs. Alright, so concavity and inflection points are always connected with the second derivative. So if they say anything about concavity, and you're going to see kind of down here, concave up, concave down, as soon as you see that vocabulary, you want to think second derivative. And same deal with inflection points. If it says something about an inflection, you want your second derivative. Okay, and the second derivative tells us the concavity, which tells us how f of x curves. So I'll show that in this space here. So we have a test for it, the second derivative test for concavity. Suppose that f double prime of x exists on an interval I if the second order derivative is greater than 0 on that interval, then f of x is concave up on that interval. So the way I think of it, I'm going to show these. Let's get these people involved. Okay, so there we go. So there's a person, and sometimes I'll circle it all the way, but this is the sign of our sign of f double prime of x. This shows the type of concavity. So when your f double prime of x is greater than 0, so that means it's positive, then we know f of x is concave up, which makes this type of shape. Okay, so this is concave up. So concave up, it looks like a cup. So C period up spells, well, I guess sort of spells cup if you get rid of the period, but concave up looks like a cup. So you can think like it holds water, concave up. Okay, so this is the sign of the double derivative, second derivative, and then this is the shape of how concave up looks like. Whereas if f double prime is less than 0, so that means it's negative. And the reason I drew two pluses is because it makes it look like a person. Okay, so you could get rid of one of them and make it look like a cyclops if you prefer. Okay, but usually I just show it with a person, and we even show a circle, so make it like a smiley face. And it looks, we have this. This person actually has a name. It's called Minnie. I started right, Maxie. Minnie. Okay, so for minimum, okay, so because if you have something that's concave up, technically you would have a minimum at some point as well, or you could have a minimum. So that's why this person's called Minnie. Anyway, so the main thing is right here, the sign and the type of concavity. All right, where the second derivative is negative, so we'll usually do two symbols, just again to make it look like a face, and then we'll draw a frown. Okay, so this is the sign. Let me make that S better. Okay, so this is the sign of f double prime of x. And again, we just write two signs to make it look like an actual face instead of just a cyclops-looking person. Okay, so sign of f double x, f double prime of x. So this is the sign. If that is negative, or if it's less than 0, then f of x is concave down. So that's what this is. F, well, let's write it as f is concave down. So the actual f, not f prime, f is concave down. Okay, and so the way I think of it, concave down looks like a frown. So it kind of got a little rhyme to it. Frown, concave down, frown. Okay, so, and then this person would be called Maxie, because you have a chance to have a maximum depending on the situation. But we have the first order derivative test tells you about minimums and maximums. Okay, so that's why I have them named, but we have the first derivative test is a little bit better for that. Okay, so anyway, and this, I wrote concave up, I should put f is concave up, the actual f. So the sign of the second derivative tells you about the concavity of f. All right, and then the last bullet there, an inflection point is the point where concavity changes. Inflection points occur when that second derivative is equal to 0. All right, so let's show this graph, or given this graph, let's find these. So given the graph, and it is just f of x, so that means I want to look at these types of shapes when I'm looking at concavity. It's asking, where is f of x concave up? All right, so let's go ahead and let's do that in blue. So concave up, again, looks like a cup. I'm just highlighting the blue there. All right, well, it looks like a cup here, or you could say it looks like a smile if you really want. Oops, let's try to draw that a little better. Okay, so I'm trying to follow the curve the best I can. So it looks like a cup until about probably there. And then it starts to frown. Okay, so then it starts to frown. So where I have a frown looking thing. So about there, put a big dot. And it starts to frown. And so we're eyeballing it. We don't know exactly where, but probably about here. Is that a good guess, you think? To where it starts to look like a cup again. Okay, so you've got your concave up, concave down. There we go. Okay, so there's those, and let me put that as a big dot. All right, so we have this. So where, and I didn't label the concave down, so concave down looks like a frown that I'm doing in red. All right, so where is f of x concave up? So we write it as an interval. So wherever I have blue is where it's concave up. Okay, so left forever, so that's negative infinity to, what do you think that is? 1 and 0.8, I guess. 1.8 on our x. Okay, so it's an estimate, so you could say 1.5, you could say something different. I'm going to say negative 1.8 because it's on the left. Okay, so I went 1 and then a little bit over negative 1.8. And then the next time it's concave up, let's use our union symbol, begins maybe at 1.5. 1.5 is our x value there. And then so we've got 1.5 comma infinity because it goes right forever. Okay, and just like with increasing and decreasing, notice these are x values. I don't really need to know about the y. I know what's happening with the y. It's concave up. Okay, so that's what this is telling us. It's concave up there. All right, and then where f of x is concave down is looking like between the negative 1.8. Oops, parenthesis was too soon there. Negative 1.8 comma to 1.5. Okay, so that interval in the red, that's where it's looking like it's concave down because that looks like a frown. Again, it doesn't have to match exactly the frown. Notice it's not like perfectly symmetrical, but this is where we get our frown-like shape. Okay, and then the inflection points. So the inflection point is the actual point. So this looked like it was negative 1.8 comma. The y-coordinate maybe is 0.5. Okay, so that is one of the points. So negative 1.8 comma 0.5 is one of them. And then we have another one. Our x value is, we said, is about 1.5 comma, and then 1, 2, maybe 2.5 down, so negative 2.5. Okay, so we have these are the inflection points. And I wrote the word "and" in there just to remind myself that these are actual points, not intervals. So it's a little confusing because you use parentheses in two separate cases. But that is our inflection points. Those are our inflection points. Okay, so that's where the graph again changes concavity. All right, so let's take a look at one other one that looks a little different. So given the graph of f of x, so it's still f of x. So not the second derivative, just f of x. Let's find the following, where f double prime of x is less than 0. Okay, so that whenever I see the second derivative, I usually just draw these two people. Okay, so in that first one, let me try that. There we go. Okay, so I know those are the signs, and then this is the concavity. All right, so what this is telling us, this is f double prime is less than 0. So this is asking the same thing as where is, so here's f double prime less than 0 because it's negative. Where do you have concave down? Because it looks like a frown. So this is the same thing as looking for concave down. Okay, so concave down, I'm going to keep my red going. Concave down, so be careful of the order, so they kind of switch the order here. So concave down looks like a frown. Okay, well, it looks like I have a frown here in the middle, and I'm just picking where I see the frown first. So that's a frown, right? There we go. So there we've got a frown. This is frown-like. So notice right here is looking like a frown. Okay, so I don't have that exactly. So I put dots there to show, hey, it looks like a frown. But sometimes graphs don't make it look exactly like a frown. That's okay. We know it still is frown-like. It's definitely not looking like a smile anywhere. Okay, so this is still concave down here in the red. Okay, so it kind of levels out. That's okay, but it's still concave down there. All right, so it looks like we have our intervals. This looks like that's concave up. So where f double prime of x is greater than 0, that's asking for where it is concave up, where f is concave up. Concave up, and that one was where f is concave down. Okay, where f is concave up, that's where I have a cup or a smile-like. And again, I don't have it exactly, but it looks like if I were right here, that looks kind of part of a smile, and it doesn't curve up. It doesn't curve up like an exact smile, or it doesn't curve up like a cup exactly, but that's all right. So it doesn't have to match it identically. Okay, but we do have it. It is all right. So this just levels out instead. That's okay. And this looks like it just kind of goes up forever. That's okay too. But this is still concave up. Okay, so it looks like we have our answers. So where f double prime of x is less than 0 is I marked it in red. That's where it's concave down. And so it looks like we'll assume it goes left forever. So negative infinity to, it looks like we have an asymptote there at -2. And then it has a break, and then it picks up again at -2. And then it goes until it looks like the asymptote at 1. All right, so there's that. Okay, and then it asked where it was concave up, which we marked in blue. It looks like it starts at 1, and then it goes to infinity. Again, assuming that goes on forever, assuming these are asymptotes, so I put the little arrows there. Okay, so there they are. And then on number 3, it's asking where does f double prime equal x? F double prime of x equals 0. Okay, so that would be where there's a change in concavity, but the change in concavity we might have left off a little bit. So an inflection point is where there's a change in concavity, but it still has to be an actual point. So that point is important. And so this portion, so this is where we would have an inflection point. And we do have a change in concavity, so it went from concave down to concave up. But at that change, there was no point. It was at an asymptote. Okay, so the change from concave down to concave up did not have a point. Okay, so we don't have an inflection point then. So no inflection point in this problem, no inflection point. So this first portion would never be true, where f double prime of x equals 0. This is actually never, because we're thinking inflection point, but there was none because there was no point. Okay, so the asymptote is not a point. Okay, but where f double prime of x is undefined, this is where those asymptotes are. Okay, so this is where those asymptotes would be. Okay, so that's at x equals -2 and x equals 1. Okay, and notice the notation difference. Inflection points I actually wrote as an x coordinate, y coordinate. Here I couldn't really write points, so I just wrote where it occurred on the x's. X equals -2 and x equals 1. Okay, so that's concavity. So that's how it's describing curves. So now if they say concave up or concave down, we kind of know what the graph should look like. All right, and if they gave us an actual function, I mean, we could always plug it into a calculator to verify. All right, which is what we'll do next in these ones. But let's save that. I'm going to stop this one now. So thank you for watching. If you have questions, let me know. Otherwise, I'll see you again next time.